In this video, you're going to see what exactly is K-means clustering. So let's begin. So first of all, let's see what is K-means clustering. So clustering is a classification of objects into different groups. So here we're going to classify them into different groups. That's all. Clustering means differentiating them into different groups. One more precisely, the partitioning of data set into subsets. So here we have a complete data set, and that one we're gonna subset it like train and test. But in train and test we're not using clustering. It's just like train and test. So that the data in each subset shares some common trait, often according to some defined distance measure. So here we're going to classify it using many features. That's like distance. We calculate their distance and classify them. So I'm going to show you guys that. So common distance measures. So how do we even measure the distance? There should be some formula. You can't just say this is near, this is near. So let's check that. So here distance measure will be determined how the similarity of two different elements is calculated. So here the first one is going to be Euclidean distance, also called as two-norm distance. So this is a type of method used for calculating the distance. So let's see its formula. So here D, that says distance, and D of x and y. So here we need to calculate the distance of x and y. So we're going to say D of x and y is equal to, we're going to say x1 minus y1. So this is going to be the formula that says x1 minus y1. So here there's another method of calculating the distance, that's Manhattan distance. So here it's going to be the cube. No, here it's going to be the square root of x1 minus y1. And what this means is it's going to be the square root of x1 minus y1 square minus y1 square. We're going to square it. Okay. So here we're going to say x1 minus y1 square. Here what is it? We're going to just say x1 minus y1. So what is K-means clustering? So K-means algorithm is an algorithm to cluster an object based on the attributes into K partitions, where K should be smaller than N. So let's see that. I'm going to show you guys in an example also. So here K values, we're going to define how many clusters we need. Clusters in the sense how many groups we need. So we are going to input the groups, and then only we're going to get the output saying that these are the groups. So we're going to check few attributes in them. So K should be a positive integer, because we can't just make it as a negative integer and then define, like you can't just group them using negative integer. So here K is positive integer. The grouping is done by minimizing the sum of squares. So you get the sum of squares of distance between data and the corresponding cluster centroid. So here we're going to find out the centroids. So how many clusters we have, those many centroids we'll have. So the grouping is done by minimizing the sum of squares of distance. So we're going to sum the squares of distance. So every square of distance, and we're going to sum them up. Minus, we're going to subtract it by cluster centroids. So how does this K-mean clustering work? So first of all, we're going to start by, we're going to take the number of K clusters. So number of groups we need. And then we're going to get the centroid from it. So we have to get from every cluster we need to get a centroid, and after that we're going to get the distance of objects. So we're going to, after getting this centroid, we're going to get the distance of the objects, like this much distance of objects to centroids. So we're going to check the distance that I showed you guys the formula that says distance, the square of distance of. So what we are going to do is we're going to sum the distance square, and we're going to subtract it by centroids. We're going to do that in the third step. And then we're going to group them based on minimum distance. So here if we have no object, no groups, then end that up. That's it. So we're going to check the steps here. So first we're going to begin with the clusters. We're going to check the number of Begin with the decision of the value of clusters. So k is equal to number of clusters. As I told you guys, k is equal to number of groups or number of clusters. So second part is put any initial partition. So we need a partition over here that classifies the data into k clusters. So for classifying it, we need the distance, as I told you guys. You may assign the training samples randomly or systematically as the following. So first you have to take the first k training sample as single element cluster. So, or you can, if you don't have training or testing one, you can just do your own data. That can be done here also. Or you can just use training or testing, or normal ones, split them into training or testing. So take the first k training sample as single element clusters. So here we're going to take every sample as single element clusters. We're going to just plot them up, and then we're going to decide the cluster. I'll show you guys in Jupyter Notebook. Then assign each of the remaining training sample to the cluster with nearest centroid. So here we're going to check the nearest centroid. After each assignment, recompute the centroid of gaining cluster. So after every group, we have every cluster. So we're going to set the clusters in the plot. And after this, we take each sample in sequence and compute its distance. So we're going to subtract the sum of the square of distances by the centroid of each cluster. If sample is not currently in the cluster with the closest centroid, switch this sample to cluster and update the centroid. So here, if you say if the data is currently not in a form of cluster wise, or all are just like spread it out, then what you're gonna do is you're gonna switch this sample to a cluster. So suppose you have an outlier, and then you're going to check each distance of the outlier, or you can remove the outlier. You're going to check and you're going to group them up, gaining the new sample and the cluster losing the sample. As I told you guys, you can remove it up. Repeat step 3 until the convergence is achieved. So until this is achieved, keep repeating it, and that is until a pass through the training sample causes no new assignments. So here we have, as we put number of groups that we need, so there should be no new, no clusters other than that. I mean, like no other data point it should be in the cluster. So till then you're gonna repeat this step 3. So let's see a small example. So this is not a real-time example. So here you have a group, it's a column called as individual, then variable 1 and variable 2. So these are just a value. A simple example showing the implementation of k-means clustering algorithm. So here we use k value as 2. So now you can just guess the centroid. This centroid is going to be this third individual, and it's going to be somewhere near the fifth or fourth individual. So randomly we choose the following two centroids. In this case, the two centroid are M1, that is, I told you guys here. This is the first centroid, and this one is going to be the second centroid, as I told you guys. So here we are just taking two random centroids. Randomly we choose two following centroids. I told you guys, this is just a random centroid. And then individual, the group 1 is this and the group 2 is this. This is individual and this is the mean vector. So mean vector here is going to be 1.0 and 1.0, and in the second centroid, in the second group is going to be 5.0 and 7.0. Step 2, thus we obtain two cluster containing 1, 2, 3 and 4, 5, 6, 7. So our new centroids are, so M1 this is this, M2 is this. We get the value like 1.83 and 2.33, and here 4.12 and 5.38. So here we have calculated the distance, that's it. So we are calculating the distance in two sides using Manhattan and also using here we calculated distance using Manhattan and also Euclidean distance. So these are the two values that we got. And now we are using these centroids. We compute the Euclidean distance of each object shown in the table. So you can see here in the table, we use this and we compute the Euclidean distance of each object. Therefore, the new clusters are, the next centroids are. So we're going to take the next centroids, that's 1.25 and 1.5. So these are the two centroids, next two centroids. They should be equal. The two clusters are supposed to be almost equal. So the clusters obtained are these. Therefore, there is no change in the cluster. Thus, the algorithm comes to halt here. And the final results of two clusters are. So here we checked it again. We recomputed it with a new centroid, and we are checking the value of each centroid. So here we took a new centroid, and the result we got is same. 1 comma 2 is one cluster, and this is the first cluster, and this is going to be the second cluster. This 3 4 5 6 7. So here we have two clusters. We have choose this as two clusters because here we have the same value. We have checked the distance of two centroids, and here we have taken a different centroid. I'll tell you this. So here the another centroid is 1.25 and 1.5, and 3.9 and 5.1, and we got the same value when we checked the distance. So that's why this is going to be two clusters. 1 comma 2 is a cluster, and 3 4 5 6 7 are one cluster. So then we plot it up. You can see 1 and 2 is a cluster, and then 3 4 5 6 are one cluster. So yeah, now let's begin coding. So first of all, these are the necessary libraries that are needed. First of all is going to be k-means because we have to cluster the data. And then we need pandas for reading the data and about the data. And then we need matplotlib to plot the data, as we need to plot it in the form of scatter plot. So we need this matplotlib for that. And now let's read the data. So I'm going to say df is equal to pd dot read underscore csv, and then I'm going to go to my file directory where I've saved it. I'm going to get it. Here it is. I'll just show you guys. Yeah, now let me just show you guys the data. So yeah, this is going to be the name, the age, and the income. So this is basically, we are going to see the age and their income, and we're going to group this up. Like these people are of intermediates, beginners, advanced people. Like that, we're going to group them up. So let's do that. So I have read, this is how our data is going to look like. We have 21 names with their age and with their salary. So yeah, let's begin. So first of all, so this is how our data is going to look like. So first of all, I'll show you guys how we'll plot. I'm going to show you guys plotting it up. So I'm going to say plt.scatter as we're going to plot the scatter plot, and I'm going to say df because we're plotting this data. I'm going to say df dot age. So here we're going to plot this age with income. So I'm going to say df dot age, comma df of income, and I'm gonna put up the dollar symbol. Okay, I have done a mistake. This should be in capital. Income. What's wrong? I think everything is right. Yeah, I'm gonna end it up. I'm gonna end this one. Yeah, I think everything is right. Oh, okay. So the I should have been in capital. Let me just come this side. Yeah. Let me copy this up this much. That would be better. Let me run this. Okay, what's the mistake? Yeah, key error. What? I don't know why is it showing a error. Okay, let's just open it up in Excel and let's change it. I'm gonna go to the Excel file. Yeah, here I'm gonna remove up the dollar symbol. Yeah, so this is how it's gonna look, and I'm gonna close. I'm gonna save it up. Oh, okay, desktop. Okay, yes, yeah. And now let me just rerun this up. Enter. The dollar symbol, I'm gonna remove it. Yeah. So yeah, this is how it's gonna look like. Let me just set the x and y labels. I'm gonna say plt dot x label, plt dot x label, and this x axis is going to be of age. So I'm going to say age, and this y axis is going to be of income. So I'm going to say plt dot y label of income. Yeah, let's run this. So you can see income, age. And now what I'm going to do is I'm going to say km. That's just a variable. I'm going to say km is equal to k means, because I can't keep writing that k means. So I'm going to say is equal to km dot fit underscore predict of df of age and income. Age comma income. km is not defined. Oh, okay. Okay, let's just do this thing. I'm gonna say k means is not defined. Come, it's right here. K means, I don't know what's wrong. Okay, km should be capital. Data frame object is not callable. Okay, yeah. Let me just make this like this. This. Let's try this. X value. Oh my god. X value is going to be of age and this is going to be of income. I don't know what's missing. One requirement for positional argument X. X is going to be age. Oh no. Let me just write it like this. Not found in index. Yeah, so it's not found in index and now they're saying, okay, so let's just do one thing. I'm gonna put this as y underscore predict. I have copied it for my I've copied it from my reference file. Okay, let's do one thing. Let me just copy up the same line like that I've done here. That says you're gonna predict this like y underscore predict. Let me just do that thing, and here I'm gonna remove this income. Yeah, so the problem over here was the n clusters. We didn't put the number of clusters, so the computer got confused saying that you don't even have the x value. What are we supposed to do with that? So that was the problem. So yeah, let me just show you guys the y predict value predicted. Yeah, so it's going to be an array because you're going to predict it up. And here we are just predicting it for the clusters, forgetting the number of clusters. Like you want all the clusters, different clusters, all of them to be, I mean like first cluster, all the data points should be together. Second cluster, all the data points should be together. So like that, if you want, you need this y predicted. So yeah, now one last thing we need to do is we are supposed to get the centers of it, and then we're going to just plot it up and call the legend. So first we have to get the center. So what we are going to say is we're going to say k underscore m. Okay, it's small k. I'm going to say k underscore m. Okay, km dot cluster. So I'm going to say km clusters underscore center underscore clusters underscore center. Oh, okay. Okay, I have to make it as cluster underscore centers. So yeah, these are the three centers that we have. We're going to get the centroids over here. And now we're going to just plot it up. So I'm going to say plt.scatter as we're going to plot it in a form of scatter plot. And I'm going to say df1. I'm going to say df1. So that's going to be, okay. Oh, okay. Modeling 5.30 f2f1. Okay, so before this we have to initialize variables called df1 and all. So I'm gonna say df1 is equal to df of, let me just put a square bracket. I'm gonna say df1 is equal to df square bracket df dot cluster. Okay, we are gonna say cluster is equal to 0. So we're gonna do the same to df2 and df3. Let me just come down and paste it. So this is gonna be df2 and this is gonna be df3. So here is gonna be 1, here is gonna be 2. So let me just run it. Clusters. Cluster. Okay, it's just a bit of small problem. Cluster, everywhere a cluster is working other than here. Okay. Let me just rerun this the whole thing. It's gonna work. df1 is okay. Here I don't know what's the problem here. Cluster. So yeah, we have done a bit of mistake. That's not a big one, but we have done a mistake. What we're gonna do is we're gonna say df of cluster. If you don't do this, you're gonna get the error is equal to. Here we're gonna say y underscore predicted is equal to the cluster. Yeah, so it's gonna work now. So we're gonna plot this scatter plot, the df1. So here we're gonna plot df1 dot age, comma. I'm gonna plot df1 of income. Okay, income. Yeah. I'm gonna say comma color is equal to green. We are gonna set the color to green. We're gonna do the same to df2 and df3. Come down, enter, come down, control V. Yeah, and here is gonna be df2 and here is gonna be df3. The same over here, df2 and df3. Let's change the color over here. Let me just make one to red and another to black. So yeah, the clusters are like this. Let me just explain you guys. First we have to change a few things. Yeah, so the same thing that we did here, df1, df2, df3. So this is not that important. So I'm gonna delete up this line, and then we're gonna say we're gonna plot this scatter plot, and then what we're gonna do is we're gonna say plt.scatter. This is the main part. We're gonna say plt.scatter km. We're gonna get the centers of it, of column 1 and column 0 and column 1 from the index, and then we're putting color as purple. Like the centroids are going to be of purple, and the label, you can say, like the mark, like the thing, rather than keeping it as circle, we can just put it as into mark, and label is equal to centroid. So let me, okay, sorry, let me run this. Where have I put this? Like that. Oh, okay, yeah, so you can see here now. Oh, okay, let me just set the label up to, and say comma label. So yeah, this is how it's gonna look like. We want the label when we want the label. So let me just set the x-axis and y-axis. Let me just set the x-axis and y-axis. It's gonna be like this. Okay, let me just set their label at least, like to income. Label is equal to income. Let me copy this up because all of their label are same. Yeah, see. So income, and this star, as I put the marker over here as into, you can see the stars over here. Like this is going to be first centroid, this is going to be second centroid. So the centroid for these black ones is this, and the third one is going to be this one. So yeah, now we know what's exactly a K means clustering, and also we know how to use this using Python code. That's great. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.